Now, scientists weren't sure how to explain how coordination compounds were built. You know, what is the bonding in these compounds? So, the data that was explained focused on COCl3.N-NH3 and IRCl3.3NH3. 4 coordination compounds were used to explain the bonding between the metal cation and its ligands. Here's what scientists in the middle 1800s observed. A compound with the formula COCl3.6NH3 conducted electricity very well. And when a solution of this compound was mixed with a solution containing Ag3+, 3 moles of AgCl precipitated. When a compound with the formula COCl3.5NH3 was made into a solution, it had moderate conductivity. The conductivity wasn't as high as in the first case, and 2 moles of AgCl precipitated for every 1 mole of COCl3.5NH3 used. The third compound, COCl3.4NH3, had very low conductivity when compared to the first 2 compounds. And 1 mole of AgCl precipitated per mole of COCl3.4NH3. Scientists at the time were unable to make COCl3.3NH3, but made a closely related compound, IRCl3.3NH3. They measured the conductivity of a solution containing this compound and found it to be non-conducting. They also observed that the number of moles of AgCl that precipitated when mixed with a silver plus solution was 0 moles. So, how did chemists at this time explain this idea, or explain this data? So, at the time, organic chemistry was very important, and many of the fundamental ideas behind organic chemistry were developed. Blomstrom, he introduced a description of the bonding in COCl3.6NH3. He said everything was bonded to cobalt in chains. So, cobalt was bonded to NH3, and then NH3 could form 5 bonds. The NH3 would form 1 bond with, the nitrogen would form 1 bond with CO, 3 bonds with H, and 1 bond with another NH3. With this arrangement, Blomstrom suggested that the structure, the bonding, in COCl3.6NH3 had CO at the center, bonded to a chain of 2 NH3s and a Cl, another chain of 2 NH3s and a Cl, and a third chain containing 2 NH3s and a Cl. Chains of NH3 were bonded together much like carbon chains. So you think of organic compounds as containing CH3, CH2, 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 CH3. Blomstrom said that NH3s could also bond together in chains. His initial description did not explain why there were different conductivities and different amounts of AgCl produced when a solution of these compounds were mixed with Ag plus solution. Jorgensen went on to further the description Blomstrom initially came up with. When he looked at COCl3.NH3, he said that the length of the NH3 chains could change. So, CO could be bonded to short chains containing only one NH3 and one Cl, and longer chains containing 4 NH3s or 3 and 1 Cl. If the chloride was directly bonded to the cobalt, it could not be removed. However, as long as there was an NH3 in between the cobalt and the chloride would dissolve and form an ion in solution. Looking at this first example, all three Cl groups are not bonded to the cobalt directly. That means all three Cls should dissociate from the compound. This should have a very high conductivity and should produce 3 moles of AgCl per 1 mole of this used. In the second one, where we have only 5 NH3s, 1 Cl must be directly bonded to the cobalt. The other 2 still have ammonias in between cobalt and the chlorides. This compound should only have 2 Cls that dissociate from the compound and should be moderately conducting. In the third compound, we have 2 chlorides directly bonded to cobalt and 1 with 4 ammonias in between the chloride and the cobalt. That means only 1 chloride should dissociate from the compound. And this compound should have a very low conductivity, and only 1 mole of AgCl should form from 1 mole of this compound. Finally, when looking at the iridium compound, this structure suggests that 2 of the chlorides are stuck directly to the iridium and cannot dissociate from this compound. However, there are 3 NH3s between the iridium and this chloride. This one should dissociate, giving a low conductivity and having 2 Cl minuses directly bonded to IR. However, this compound has 0 conductivity and does not precipitate any AgCl. Jorgensen's structure suggests it should precipitate 1 Cl minus or 1 AgCl and should have a very low conductivity.